Earthquakes happen when there is a collision between tectonic plates. There is a subduction zone around the Pacific Ocean, indicated in red, and Chile is one of the countries on it. In 2010, there was an 8.8 magnitude earthquake in Chile, causing 525 deaths in total. Based off this particular earthquake, we did 3 experiments in different disciplines, which are structural engineering, geotechnical engineering, and transportation engineering.
O'Higgins Tower, a brand new structure, was severely damaged in the 2010 earthquake. The iron rods used in the O'Higgins Tower was much thinner than those required, and the pillars were too few and far apart, which are the main reasons of the failure. We started off the challenge by replicating the O'Higgins Tower, keeping the same dimensions but changing the structural design to withstand the earthquake. We added bracing between beams and columns, forming a triangular structure. The video shows our structure on the shaking table. We have successfully prevented the egg from falling off.
The failure of Las Palmas Dam caused the deaths of 4 people. The dam was built with the residue from a nearby mine. In the workshop, we used samples of the soil taken from the dam to find the angle of repose, the angle which forms when a granular material is poured on a singular point, similar to how the dam was built in the first place. After accelerating a container with a small slope of the material inside, we observed how the soil acted when an earthquake-like force was applied. The soil displaced, taking up a large surface, and a new angle was formed. The stronger the force, the smaller the angle becomes, and the larger the displacement. For a future dam to resist earthquake forces, the angle of the slope must be small, reducing displacement. The factor of safety depends on the angle of the dam. The smaller the angle, the safer the dam.
In the workshop 3, we analyzed the National Stadium of Santiago. The objective was to plan an escape route, allowing everyone to escape within 8 minutes. There are 3 large open areas next to the stadium, and we have calculated the time taken for each zone to evacuate. We have included the main factors that slow down the moving pace of people in our calculations, such as population density and flow. The evacuation time for all 3 locations are under 8 minutes. Our evacuation plan maximizes the number of survivors in the stadium.
In conclusion, an effective earthquake-proof structure is designed to fail with warning, giving people time to escape. Escape plans must be as efficient as possible to make the most of this limited time. We must also predict the movement of the natural structures to limit dangers and hopefully save lives.